part of this chapter is about molar concentration or molarity, which we show with capital letter M. Let me grab my pen. So, this is the first and the most important unit for concentration of liquids that you learn. It's first of all shown in uppercase M, capital M, and then it's moles of solute per liters of solution. You know that in each solution you have the component which appears in a less concentration, which is called solute, and also you have a solvent. So an example of solute and solvent in some lemonade. What is the solvent in lemonade? I'm sure you will say water. And the solutes are the flavors and sugar. So solute and solvent together will form solution. You will learn more about solutions in details at the beginning of General Chemistry 2 course, but that's good to have it as an introduction. So, when we say molarity is moles of solute per liters of solution, means moles of the substance that is dissolved in a less amount over the liters of the entire solution. You will have other units of concentration like molality and mass percent and mole fraction, but molarity is the most important and the most common unit for the concentration of liquids. When you go to lab, if you pay attention to the bottles that are prepared in the prep room, you will see these numbers. Like you will see a bottle of acetic acid is 0.1 m, means 0.1 molar, means 0.1 moles of solute per 1 liter of solution. What we can do with concentrations, one of the things is dilution. Let's go back to the same example of lemonade. First of all, dilution is making a less concentrated solution from a more concentrated solution by adding solvent. Let's say you are tasting some lemonade and it's too sweet. What do? Do you take any molecules out or you just add water? Of course you add water. So you are diluting your lemonade. That's the same thing with chemical solutions. There is a formula to use for dilution. This is initial and this is final. The logic is that the number of moles of solute before and after dilution don't change. I tell you, in the lemonade, you don't take any moles of solute out. You just add the water, you add the solvent. So, molarity times volume is number of moles. So, if the number of moles of solute before and after dilution are the same, you can open the mole to molarity times volume. Why molarity? What is the unit for mole? Mole, right? MOL. Molarity is moles per liter. You have it here. I mean, in the previous slide, moles per liter. So whenever you have molarity, you have moles per liter, and the unit for volume is liter. When you cancel liter and liter, you will end up having mole. The same thing for the other side. Moles per liter times, there is going to be moles F, moles I, and you will have Ni is equal to Nf. So this is the formula you need to keep in mind. MIVI is equal to MFVF, or M1V1 equals to M2V2. That used to be one of my favorite formulas when I was a student. Oops. Alright, so let's work on a dilution question. What volume of a 4 molar solution of hydrochloric acid is required to make 125 milliliters of a 0.5 molar solution. What are the hints that show this is a dilution question? Is that, first of all, we're talking about one type of chemical. What is that? HCl. Second of all, let's write down what we have and what we need. What volume of 4 molar solution is required to make 125 milliliters of 0.5 molar solution. Another hint is that you are going from high concentration 4 to 0.5 molar. So high concentration to more concentration. So what would you use? MIVI is equal to M2V or MFVF since we are using initial and final. So what is MI for? VI is, we're solving for it, and MF is 0.5 molar. What is the volume? 125 milliliters. You don't need to change the volume to liter because we're going to find the initial volume in milliliter also. As I calculated, it turned out to be 15.6 milliliters. I hope I haven't made any mistake. Please double check the calculation. So it's 0.5 times 125 milliliters divided by 4, right? The known side divided by unknown side. So that's the dilution type of problem. Another topic or area that you can use the concept of molarity is titrations. Titrations is a technique, is a method to determine an unknown concentration of a substance by gradually adding a certain volume of another substance which has a known concentration. The most common type of titration is acid-base titration. You will have an experiment about it in the lab, and this is one of the techniques that any student that has worked in a chemistry lab must have tried it at least once. So for acid-base titration, we have a modified form of dilution formula. Take a look at dilution formula again. What was it? MIVI is equal to MFVF. Let's go back to the titration, to acid-base titration. You see MAVA over NA is equal to MBVB over NB. I need to redo it. Okay, so the acid side and the base side. We say it's the titration between an acid and a base. So molarity times volume divided by just need to do some NB, number of moles of base, equals to MBVB over moles of acid. Write it down on your notes until I go to the next page and we will work on a question to apply this formula. You might be confused like, hey, this is the acid side. Why did you put number of moles of B there? I will tell you why in the next slide. This is a titration problem. How much of a 0.1 molar NaOH is required to neutralize, because we are neutralizing the acid and base, to neutralize 25 milliliters of 0.2 molar sulfuric acid solution according to this equation. So what was the equation again? MA VA over NB is equal to MB VB over NA. You need to use the number of moles because according to this balanced equation, each mole of sulfuric acid needs 2 moles of sodium hydroxide. So the number of moles is not 1 and 1. You have to take that into consideration. So let's do it. Let's start. MA is molarity of acid is what? 0.2. 0.2 molar times, what is the volume of acid? 25 milliliters divided by number of moles of base is 2 is equal to number of moles of molarity of base. Molarity of base is 0.1 and times volume of base, we don't have it, divided by number of moles of acid. So volume of base would be 0.1 times 2 times 0.2 molar times 25 divided by 1. So is it going to be 100 milliliters? Let me calculate it real quick for you over here. I'm sorry, this is just 1 milliliter. Okay? In reality, you will need more, but it was just an example on the board. Actually, you're not going to use it in the lab. Other topics related to this molarity are gravimetric analysis, quantitative analysis, volumetric analysis, which is related to titration. You have all of them at the end of chapter 4. You just need to use the stoichiometry calculations that you had in chapters 3 and some of it in chapter 4. So I want you to work on those questions. If you still have any questions or problems, let me know, but these are the main concepts of this chapter that I wanted to work on for you. I hope it was useful, and stay tuned for chapter 5.